Okay. Hopefully it's back up. Right. What I'm gonna do today is take some of these RC cars, very cheap RC cars, about 10 euros, with tank steering, which is a feature I was looking for. Break them open. I've already done it to this one and gutted it out, and then try to make an ESP32 cam module, work with it, and be able to see something, and maybe even move the wheels a little bit if the time allows. This is in preparation for our best summer course in Cluj-Napoca, which you can see more info about it in the doobly-doo. Right. So and after I make one of these work, I'm gonna have to make another lot of 4 in the following week, and I have all components for all of them, but today hopefully I'm gonna finish one of them at least, which is wishful thinking. Right. So I haven't opened up any of the components yet, but my thinking is I'm gonna use, here we go, this is a buck converter. My intention is to use 9-volt batteries to power this, and the ESP works off of, I think, 3.3 volts, so I'm gonna use this to tune that down. The wiring is gonna be done on a breadboard, which should be approximately the same size as the car. Right? It fits kind of neatly on there. It's not gonna be on this side because it's gonna interfere with the motor's wiring, but I think I'm gonna flip everything, put it like this. Right, have the breadboard like this, the ESP somewhere around here, other components towards this end, maybe a battery in this slot. I'm not sure. I'm gonna figure that out as I go. Right, of course. So we've got the buck converter, we've got an ESP32 cam, which is, as the name might suggest, an ESP32 with a camera. And also, let me make this public while I'm at it. Public. Let's go. And can I share? Yeah, that's. Alright, also while everything's loading on my laptop, another component we're gonna use is this H-bridge motor driver. So as you may know, microcontrollers such as the ESP32 have digital output pins through which you can control stuff, actuate stuff outside of the controller, but they can't provide a lot of power, and motors require significant amounts of power. So we use boards like these, motor drivers, that take a little bit, a very weak signal, relatively weak signal from the board. Right, the board tells it, turn the motor on, and amplifies that signal. So basically bypassing the board, sucking energy straight out of the battery instead of it going through the board and being limited. So as to power the motors with the power they require. So I'm gonna have to stick some header pins on this. And here's the ESP cam. Where's the camera? Here's the camera. it's in this sort of sandwich. The top module is the actual microcontroller, and the bottom one is a programmer thingy. So when I want to program it, I stick it like this, and then stick a USB cable in here, and I can send my code from the laptop to this, and it will be programmed. And then when I want to actually use it, I take it off the programmer board, hopefully without bending any of its pins. Yeah, I managed not to. And this is the actual microcontroller, and this is the programmer. And you can see this nice shielded circuit is the actual ESP32. It has an SD card slot, which I won't use, and many little digital pins. Right, let me throw away the packaging. And before getting to the car, I think I'll just experiment with the Arduino, so I can put my tools away, they won't be needed. One moment. Right. So I'll just keep this connected like this, and try to program at least the default sketch, which creates a web server, and I can connect to it and see a video feed. Right. So screen plus face. Right. Transition. Hello. So this is my other laptop's screen, which I'll open up Arduino. That opens. I'm gonna fix this back on and I'm gonna attach the camera module to this connector over here. Right. I'm a little bit disappointed that the camera's wire is so short. It's gonna be a little bit challenging to actually mount it properly on the car, but we'll see about that some other time. I might ask someone to make me a 3D print to mount it vertically. Right. Now, cable to program it with, which I can't seem to find. Huh. Right, here it is. Here we go. And here we go. Lights on. It just beeped in my ear. Should be right. For the SSID, I'm gonna make a hotspot, or everybody's gonna know our roommate's Wi-Fi passwords. Here we go. Right. This is the code we have here is the camera web server demo sketch for this board. In my case, I have to select this AI Thinker variant. I'm not particularly sure what any of this does. I took a cursory look through it, but it's still very complex, and I intend to minimize it quite a lot. Right. What is it today? 2022. 13. Let's go. Save. Hopefully I can. I have a COM port. There we go, COM3. Very nice. I've selected a, I think, right port COM3. Is this gonna work? Does anything blink here? Do I have to press anything? Hopefully not. Oh, it's still compiling. It has two buttons, a reset and an IO0 button. I hope none of them is required for flashing new code onto it. Yeah, it's programming without my interaction. Great. And I'll open up the serial monitor. Oh, after it's programmed. Hopefully it should print something like connect to this IP to see the camera ready use, and it's gonna give me an IP on my local network, which both laptops and the board should be connected to, if I didn't mess up the password. Right. Copy link. Hard rate resetting, right, done uploading, serial monitor. Now I might have missed, wrong baud, needs to be this one, great, but also not great, this looks like an error, brownout detector was triggered. Oh, shit, is this USB cable not powerful enough? That wouldn't be great. That would be quite bad. When it runs off of the battery, it shouldn't have this issue, but okay. I will try it on my other laptop. Hopefully it doesn't cry here as well. You won't be able to see this. Serial monitor. I need to choose the proper COM port. Okay, on my other laptop it doesn't seem to cry that much. I'm gonna reset it. Plug it in, plug it out maybe. Plugged out, plugging it in again. No output. I'm not very satisfied with this. Why? Okay, I get some errors when trying to sense data. What is it? No pointer exception. Board is not available. Okay, that's not great. Well, that sucks. Not off to a great start. Clearing this output, reset it. It's not doing anything now. What's wrong, fella? Okay, right. Power reset, brownout detector was triggered. Why? Okay, start auto scrolling. Let's ESP32. Okay, so the same camera, USB too long, USB cannot supply, USB can... Okay, I could try powering it with another USB cable, which I know can provide, I think, up to 2 amps, so that should be more than enough, but I won't know the IP address, so we're gonna have to guess it. Right. Or maybe let's. I want to try a simpler sketch. I want to try something like Blink. Check that it actually works. Samples, basics, Blink. Nice. The right board, the right port. LED built-in was not declared. Yes, can LED. GPIO 4. Okay, let's define it like so. LED built-in should be digital pin. No, come on. Okay, sure, Blink. Let's program this. Hope it's not gonna blind me. From what I gather, this is a rather bright LED. Let's see. Yeah, okay, at least Blink works. So it's trying to... Okay, it is very bright. I'm gonna turn it around. It's gonna, so that it blinds you, not me. Right. So the camera seems to be pulling too much power from too much power, and my laptop doesn't want to provide that much. Maybe I can give it a static IP and connect to that. To Wi-Fi static IP. I don't wanna have to port scan because I've had trouble with this router not allowing certain connections between laptops on the same network. Right, so not Wi-Fi begin. That's not set TLS. I don't think that would be the local IP. Is this? Can I not set? Config display. Right, Wi-Fi.config IP. Sure, that sounds great. What subnet are we in? This. Okay, I'm gonna give it. Okay, Wi-Fi beginning. Right, it's waiting to connect. Then I'm gonna Wi-Fi.config fixed IP. Const byte fixed IP 4 should be 192.168. Hopefully I'm not messing up the NDNS 200. I'm pretty sure nothing would be there, yeah. 200. Yep. Does this compile? No, it doesn't. Does it not like it being const? Oh, I have to declare it like this. Okay, sure. 200. Do I like it this way? No. I'm matching Y. This is literally the example. Does it have to be global? Okay, that's not that's weird. ESP32 Wi-Fi config. Let's go. Nothing's working. Right, this isn't the same API, but maybe I can trick them. Set IP address. What setters do we have? Node PS protocol change country. Set config. No, I don't like this. I'm gonna search for the error. Hopefully that brings up something more relevant. Right. Yeah, but this is another function. Oh, but I might find Wi-Fi class here. Yeah, let's go. So config. What? No, I think it's right. C++ maybe it's. I don't want defines God. Wi-Fi config. Maybe this finds something. This is awful. The email is with static IP. Do I have to configure everything? I don't like this, but sure. Yeah, we can do that. Sucks. So local IP gateway. I'm copying these. Sorry. I wanted 200. Gateway should be 3.1. Subnet 255 also here. The DNS is alright. Will this work? No. Right, because I found. Okay, sure. Yes, let's go. It's still gonna brown out most probably, but at least when I change the power source, we will have an IP. to which we can connect. Oh, might it actually be just the Wi-Fi, not the camera, that sucks all the power? Because we didn't get any info on the serial monitor, so it probably died here before it started printing anything. Wow, we've got a viewer. Right, hard resetting, and it's most probably browning out right now. Yes, it is. Right, but if we change the cable and give it a little bit of time to wake up, ping 192.168.3.200, will it answer? Yes, it does. Okay. So it did work. 68.3.200. Let's go. It works. Hello. Nice. It also has decent frame rate. What the fuck? What if I bump up the resolution? I'm not expecting it. Yeah. We have got a webcam. Nice. What is this? Okay, so it also does some effects, and also I saw in the code it has face detection and recognition codes built into it, which is quite cool. Please select CIF or lower. Okay, sure. If you say so. Face detection, is it gonna draw a square around my face? I think that's what I saw the code do. Oh, it's very slow. It would make sense. Maybe if I get a still. Right, but it didn't detect my face. Ghosting. Face recognition. Get a still. On my face. I don't know what to expect. Right. What happens if I take off this protective film? Nothing, surprisingly. Okay, so the face detection doesn't necessarily work, but that's not something I was looking forward to using in any case. I'm kind of bummed that the code that the board sucks too much power to be usable with the laptop, but that's fine. Right. Okay. I'm curious, can I do stuff like getting video from MATLAB? Because we know the address of this stream, right? It's here. Oh, and I don't think it likes more than one client at a time. Yeah, but that's fine. Can I like in read? No, not in read, in load. Okay. No, okay, is it in read? And HTTP. Wow, is it actually working? It doesn't really like that. Try not found, cannot read URL. What do you mean you can't read? Dummy. Get me a state. What does this do? I'm curious what's getting a still versus getting the live stream. What the difference is? Get still button on click. Oh, so it has a URL capture as opposed to stream. Okay, sure. Great, so I guess the next step would be, now that I know it kind of works, I want to prepare the car to... That's why I'm putting this out. While I was playing with the car, it broke. One of the wires broke loose. And I want to fix it back, and also actually, right, so let's swap this around, right. One of the wires that connect to a motor broke loose, and I also want to wire the H-bridge and basically everything to make a very simple, maybe a very simple sketch, maybe move the car forward or make it turn around in circles. Right, and for that we're pulling out the soldering iron and not dropping everything everywhere, hopefully. I bought myself shiny new tips because the the old soldering iron tip is oxidized to hell. It also broke off when using, I don't even know, maybe the heat made it brittle, but in any case it was horrible, and so I bought new shiny tips. Right. Right, it started. I hope I won't destroy the car with the heat. Okay, I'll first leave it to smoke a little bit because it's brand new. In the meantime, I'll wet a sponge, though I shouldn't leave this unattended. Be right back. I stopped it. Doesn't fit, but that's alright. Start this again. Blast it at full heat. Can you see the smoke? I don't think so. It's not warm yet. Starting to warm up, started to fizz a little bit. Also, while this is warming up, one neat thing about the breadboard I chose is I think the ESP ends, yeah, right, the ESP and the motor driver. Oh, actually, no, I thought it was much smaller. I thought they fit just, it was like there were no extra rows, but apparently there are plenty, so no problems with that. Are you warm? Yeah, warm enough. Kind of. I don't think my sponge is wet enough. Yeah, it's warm. Okay. I turn it down. A bit of extra solder. Come on. Don't be shy. That's perfect. Cool. So now the motor, if I salvage the 9-volt battery out of my multimeter, which is not something I'm particularly proud of, the motor should spin if I connect it to these wires. Can I hold this in some, yeah, like this? And I think this way the motors will spin freely. Yeah, there we go. And another one of the things I really like about this particular car is that it has tank steering, and the two wheels on each side are coupled, so when I turn one, the other also turns. So we only have two motors to worry about. And I think the kinematics will be slightly easier than if it had like the normal kind of steering with a servo turning the front wheels. That would have been slightly harder, though in the course Mr. Matsakis has a lecture particularly on this subject. How do you do the kinematics on different kinds of sort of layouts? I don't even know how to call them. I want to call them car topologies, but that's so wrong. Why do you not work? You can fell out. Come on. Yeah, okay, it does work. Great. So as I said, I'm gonna be working on this side. I want to see if the breadboard and battery fits maybe like this. And they kind of do. Can I fit the battery like this? Kind of not. I'm not very happy with this fit. Right. Can I fit the breadboard on this side? Because I know the battery fits on the other side. Potentially. Right. Got sidetracked a little bit. Let's wire up the H bridge. And hope I don't. Right, I broke the headers nice and evenly. I'm curious where I could position them so that they're straight. I know actually what to use. Here it is. I once bought these very fucking sucky proto boards, thinking they were very cheap. Well, they were very cheap, but that meant there is no copper. It's just a bunch of holes. But that's great in my case, because I just want to have something that would resist the heat. And hold these pin headers upright. So this is great. Nice. Nice and tidy. Right. So with this I have, yeah, so I have the motor driver, and now I'll have to solder each of these pin headers. Can I maybe zoom in face? Let's make a second scene duplicate. yes. Right. Transition to that. Somewhere around here should be fine. Yeah, you still can see shit. Right. Right, I have to bring some more water for the sponge. It's like it's damp, but doesn't properly work. Here we go. That's more like it. No, it's actually not warm enough. Okay, now it is good, and the solder is. If I had a proper support for this, that would be awesome. But the solder is falling off, and it's nice and shiny. Right. Oh, but it's not warm enough to melt the solder. Oops. Can I bring this closer? Yes, I can. Where? Here. Okay. Come on. Way too much solder for this one. Or? No, it's actually alright. Great. Very nice. Are the pins straight? Kind of, not really. But I think they'll be good enough for the breadboard. Actually, let's try to fit them. Yeah, they fit. That's good. Let's go. Nice. The joints are a little bit sucky, but I can live with that, especially this one. I don't really like that one, but they look fine. I'm very bad at this. Right. Don't you wanna hate this? Right, hopefully that's good enough. The the joints look very bad, especially this one, which is very tall, but I think they are solid, and there is a good connection, even though they look awful. Right. Okay, I need to check with the check to see what the pins are, because apparently the PCB wasn't very well designed, and the pin headers actually cover up some of the text. Sure. But it's not that, and I don't know what the naming convention for motor drivers or this motor driver is. So this is a 8833. Is that thing? Okay, let's switch to screen space. Yep. Hello. Something like that, right? Yes, this is it. Do we have a right? So okay, but this doesn't have the same naming convention. The dumbest search terms tutorial Arduino, but you know it's gonna work. No, you do not. It has once again another naming convention. No. Right, this is my what was it? The next link? No, it wasn't. Alright. User guide. Thank you. Right, this is great. Okay, very nice. So EEP is some enable or sleep thing, and it has a jumper here. I might make the connection if that means enabling this always, because I don't think we will ever sleep. Motor power goes to GC to grounding VCC. Okay. Okay. So we have one here. Okay. zoom in on what I'm doing here, but I don't really know. It's not gonna be very visible, but I'm stripping some wires to connect this up. Right, so if that was in 1, in 2, VCC would be this one, and I've made this too short of a jumper. That's a better size. So this was in 1 into VCC ground. Okay, that's good. In 1 into VCC is here. And ground is the next one over. Got too long of a jumper. I'm gonna place it. No, I'm gonna use it for something else. Even a little bit more. Should be good enough. Perfect. Right, so that's VCC and ground, and I'll have to take care that this is the high power rail, so this will be tied to 9 volts. Yeah, and this board supports 9 volts, and I'll use the other rail for logic, for the logic level 5 volt, I think, or 3.3 volt for the ESP32. Actually, I can check the board itself to see if I would know where it is. Here it is. Right, so it's got 5 volts, surprisingly. ESP32 IO voltage. Okay, but the outputs are actually 3.3, right? Yeah, I don't like that a lot. I would have liked everything to be 3. Oh, it actually does take in it does have a 3.3 pin, so that's good. All right. So for just one motor for now. Oh, I should be able. No, I won't tie the grounds together. That sounds like a bad idea. But I could maybe wire up the buck converter. How should I put it? Will it maybe fit better on the car? Yeah, I think so. I think I'll do something like that because I want the ESP. Oh, I was okay. Let's make my let's make this big. So turn off studio mode. I hate. I was messing it up. Right. So I want the ESP32 to be right in front and have the camera looking that way. Eventually supported by some 3D printed thing or hot glue. Here you go. So I have room in the back to place a battery and power circuitry and whatnot. This does mean that I'll have to bring these small wires to the other side of the car, but that's alright, I think. Okay. So the next thing, signal wire from the ESP to the motherboard. In 1 and in 2 over here, and I want 2 PWM enabled. ESP32 cam. Will I find the pin out here? Yes, I will. Great. God, I hope all of the pins are PWM enabled, otherwise we might have to do software PWM, which would be horrible, but that's alright. Okay. Power. I won't use the UART pins. Oh, you can't see what I'm looking at. Oops. Right. I won't be using the UART pins. Oh, actually, I could be using them because I won't be talking through UART. So the board will either be on the car and using the UART pins to talk with the motors, or on the programmer and using the UART pins to talk to the laptop, so they could be reused, no problem. Okay, I will do that then. So those would be IO 16 and 0. Yes, they would. But I don't like the side they're on. I do something on the other side. Okay, GPO 12 and 13, it's gonna be good. So for the first motor, we're gonna have and some neat wires. Here we go, up to about there. Good. Okay. So I want to triple check that this was the way to use this motor. So in 1 and in 2, it doesn't say. Okay. Yeah, okay. I have. Okay, yeah, in 1 and in 2 are controlled by out, control out 1 and out 2. Good. So in2 goes to IO12, I think that is, and in 1 will go to IO13. to about there. Good. That's great. I think the okay, the ends are a little bit short. I'll make it longer and hope that it still reaches. It might be a little bit too short now overall. At a limit. Please fit in. No, I don't like this. Maybe no, I can't even swap them around. Okay, I'll have to make a slightly longer one. That was longer. Please fit. Come on. Okay, it's not straight enough. You fit now, please. Good. Cheap breadboards, let's go. Nothing ever fits, but that's fine. Okay, I think I sort of forced it in. Should be good enough. Right, so in 1 and in 2 are now wired up, and I will right next to them we've got ULT, which is set to low to go to sleep mode. I won't go to sleep. Is that what it does, or does it output whether it's in sleep mode? Let's check. The V883 ULT. Is it? Oh, fault. Okay, that's possibly where the ULT comes from. So, and fault is it controlled by? Yes, it's an output, and yeah, it pulls and fault low whenever something goes wrong. Sure, we won't be using that, but we will be using the next two pins, which are the two the first motor. Can I pull this through to the other side without breaking anything? Let's hope I can. Through this screw hole. I should really glue that in. Okay, I will have to wire some longer leads onto this. And maybe have the longer ones go through the old. Okay. Oh, you're stuck. Please, stick it in. Yeah, there was a knot. Sure. Okay, so I'll have, so maybe this should be long enough, I think. And it's gonna be longer than needed, but that's not a problem. Yeah, much longer than needed. Maybe I can cut it in half. Will half of it be long enough? Half of it, I don't think. Oh, actually, it might be. Okay, I will cut it in half. Worst case, I have to get a new wire. Straighten it up. Here we go. Straighten you up as well. And we've got out 1 and out 2. Which will go down through here somehow. Maybe through one of those holes. Yeah, that looks nice. Right. This is an incredible bodge, and I'm not particularly proud of it, but I think it works well enough for these purposes, assuming it doesn't fly out at the nearest inconvenience. Right. Save this for later. I won't be very careful about the polarity, because the worst that can happen is just the motor spins the wrong way and the students can simply reverse it, or I can swap around the wires on the breadboard. And also I don't think any fancy splicing, I guess, is needed. Twisting it around and giving it a little bit of solder should be enough. Because these small wires are so finicky, I think attempting to do something like an alignment splice would do more harm than good. I'm afraid of breaking them. Melt. Okay, not yet. This is awful. I'm not doing this well at all. Yep. Horrible. Okay. Turns out if you actually hit the wire, it does accept solder. Okay, that's good enough. Next. Come on. Don't cold join, please. Yeah, we've got a decent connection, I think. I think so. Kind of wonky, but I think it's gonna work. Right. So that is this side done. I'm gonna pull the wires through and maybe stick them with something. Maybe a dab of hot glue. Okay. Which one? This one is on the laptop. It's fine if you run out of battery. So now I have these the two wires I just stuck are there, and I want to fix them because they currently move around, and the solder joint I just made is probably absolute trash. So some strain relief will absolutely help. And after I mount this motor, I don't think I'll connect the other one. I just want to test the board with one motor, see that it works. Is there anything else I should connect here? Let's check. So we've got the VCC, ground, the two signal wires, the two output wires, one which we ignore. There's one extra pin I'm not aware of, which I think is the sleep. It's EEP. Okay, what do I do with EEP? EEP output protection. What? Are you warm yet? Yes, you kind of are. Okay. That's good enough, I think. Yeah, they're staying there, and I don't think there will be any significant shocks to actually rip the glue off. Good. So I can now connect this here and here, and the first motor is connected. Now I also have to do the power. Right. I've been avoiding this for a little while. This wasn't, I didn't plan this well enough. Should have thought about the layout a little bit more. The battery doesn't fit underneath. We've already tested that. And it kind of does, but not not very securely. And I said it would fit here, but I just wired something else there. Okay. I'm done. I might have to redo these wires. Or maybe just go with the battery underneath sort of thing. I'm not very happy about it. And I can't put the battery in front because then the camera won't see ahead. Yeah, these wires were a failure. And because I forgot what I wanted to do here, and I'm just messing around basically. Could I? Oh, but for now I don't even need a battery. I can test it with the 5-volt USB supply, which is sort of just differing the problem, but yeah, it should be alright for now. So I have this DC jack thingy, which I just dropped a bit. I used for another project, and I'm gonna cannibalize it now, but I really tightened that screw. Okay, this is good. My desk is a total mess. I'm gonna put this somewhere else and plug my laptop back in. Good. So the power shouldn't be really shouldn't be that difficult to do. I just wanna place it in a sane position, and I currently don't seem to be able to find that. And I also said I'd use a power switch. Okay, I think I'll do something like this. So I'm gonna mount this small switch to the positive input side directly, then wire the 9-volt battery to the other leg of the switch, so that in one position it doesn't provide anything, and in the other you have a circuit. Fine. But still, I'm thinking in two places at the same time, because I actually said I'd use the 5-volt power supply. Let's go. Can't even hold a thought for more than 20 seconds. Cine e cu mătru? Lol. One of the issues with this USB adapter, I soldered it before, but apparently did such a bad job that both wires really wiggle and the contact was awful and basically didn't work at all. So I have to redo it. That one looks secure. I'm done. Don't touch red hot wires, maybe. Lesson of the day. Hopefully that's secure enough. A little bit toasty, but that's alright. And this will go to the high power rail. Crossed over like so, because in this case I still want to power the ESP32 off of 3.3 volts. So I'll still need to wire up the power source. So it wasn't that bad of a tangent after all. I just have to find a place to put it. Is this good enough? Not a fan. Could I maybe reverse the whole board? Yes, but I need to change those wires. I could, just for testing's sake, wire up the ESP to 5 volts and let its onboard voltage regulator do the heavy lifting. That wouldn't be that big of an issue, but I don't want this to be the permanent solution. So, and also it's very crammed. Don't think anything will fit here. Actually, I do have enough space, but it's gonna be very messy. Right, so ground is connected awfully, and I can also wire up a 5-volt cable, which is gonna be comically large precisely because I don't want it to stay this way. It's 5 volts, goes here and here, I guess. Horrible. But I should be able to plug this in and see something happen without burning my chip. Please, pretty please. But it has no onboard LEDs. Oh, it's actually nuts inside the breadboard. Okay, good enough. Hopefully it's now connecting to the local network, and we should be able to see it do something. Yes, it works. Okay. Hello. Right. That's great. It's, oh god, this is awful. I am gonna try to wire the motors. They shouldn't do anything now, but the motor driver does have a green light, which is on. I'm not sure if you can see it. Okay. How do I do this? First, we're gonna code something up real quick. Something without the camera, a new sketch. Give me a pin mode. I said 12 and 13. Okay, 12 output, 13 output, and I'm gonna do 1 second of 10% going forward, 10% going backward. So analog write to pin 12. What's the syntax? Is it out of 255? Arduino and is it a float? A value between 0 and 255, okay. So analog write 12, I'm gonna write 20 so that it turns slowly. I don't want the car to start running off here, or maybe suck all the power out of the charger, though that shouldn't be a problem. Digital write 13.0. So it said that if you set both pins to high, you basically short out the H bridge. You do so if this is the H bridge, if you set both pins too high, it would close all of the switches, I think, or at least close two of them on the same side, and that shorts it out and it's gonna burn. So we don't want to do that. We want to make sure that one of the pins is fully off and the other one is PWM. And if we switch them around, it's gonna go in the other. The motor's gonna turn the other way. So let's say a delay of 1 second, and do it the other way. Okay. I would have also liked to still have a camera feed, but I'm gonna work on that later. Okay, forward back, let's call it. I'm gonna have to pull out the board and place it in the programmer, and this I kind of hate, that we have to do this, but I did sort of choose this on purpose, having to pull out the boards for each new upload, and I'm afraid I or one of the students is gonna break its legs, the board's legs, doing this, but that should be fixable. Right, hello, am I on the right board? I am. Upload. Analog write was not declared. Am I? What? ESP32 analog write. Come on. It has a polyfill. What? Come on. Okay. I sure hope it's not software implemented. No, it is, but that should be fine. The microcontroller shouldn't be doing a lot of work in this configuration. At least what I'm aiming for is having a robotic operating system node basically running on the microcontroller, and that's it. It sends video data to a computer, and computer takes some actions and sends back PWM values to the microcontroller, so it's not that big of a deal if we use all of its timers. But a little bit of a bummer, I didn't know this. Library manager, analog write for ESP32, sure. This sucks. do I have to... I didn't install... Oh, actually I did read the documentation. What do I have to do? Okay, include analog lights. Yeah. Do you work now? Yes, it does. Very good. And presetting, thank you very much. And I don't remember which way. Oh, I actually placed it somewhere I didn't. I wouldn't really like it to be placed, but I'm gonna leave it that way. Okay, this looks good enough. And if I wire this up, let's disconnect the power while I do this. If I wire this up here and here, we're gonna burn the board. Up, up, up. Okay, this should be fine. If I connect power, we might see it working, and we also might see it flying off. It doesn't do anything. Okay. Do I have to pull sleep down or something? Let's get some actual jumper wires. Also probe it with the multimeter. That might be smarter than what I'm gonna attempt now, but hey. Okay, what the fuck did I do here? God, this is awful. Nope. Bad. Ash. So we've got let's pull up the driver pin out. So on this side I've got in one into VCC ground. Okay, next ULT. Oh, I switched around out 3 out. Apparently it's goes on a diagonal, so int 1 and int 2 are here, and but out 1 out 2 are on the opposite diagonal, and vice versa. That sucks. I'm gonna use in 3 and in 4 then, because the out wires aren't long enough. Right. In 3 and in 4. Already wired. On that side, let's try this. Tip. Still not doing anything. Not warming up either, so that's at least a good sign. Okay. Do I have to pull EEP, which would be this pin, to high or to low? Nope. I have to pull ULT to high or to low. Nope. 12 and 13, are those the pins? They should be. Okay, I'm gonna measure some pins with the ground and oh, the motors are whirring. Okay, something happened. What did I do? Is it on the other side? Are those not connected? I don't think I could burn these motors with such little power, but they do be they're vibrating a little bit. No, not anymore. What am I doing wrong? Oh shit! Let's go! Nice. Okay, let's. I'm gonna use some actual jumper wires because I don't know what my bad wiring is currently doing and why it doesn't work. So IO12 goes to input 3, IO13 goes to input 4. Again. Not this one. Whatever. Okay. So what am I doing wrong? It does seem like I'm doing the exact opposite of what I should be doing. So when one of these is connected and the other one isn't, it does spin, but not in alternating directions. Well, I won't be using analog writes then. 12 like that, and 13, 12 the other way around. Pull this out. No, no, I'm bending pins. Here we are. There we go. And now, okay, chill. For 1 second. This is very weird. Is that not how I use this? Is it in sleep mode? It might be in sleep. The H bridge might Actually, that doesn't make any sense. And one of the solder joints is has already failed. That's not great. Okay. What's the issue? I'm worried that it might, the H bridge might not take 3 volt inputs, and that would be quite bad. I didn't check this. Shut up. I don't want your assistance. So, logic level inputs. No, it's gotta be above 2 volts, so it should be properly detecting this. What's the matter then? Okay. This is quite weird. Okay, the ground isn't connected anymore to the board. Maybe that's the issue. Maybe you have to actually power your board. Oh wow, was that the issue? Yep, the ground wasn't connected. Okay, this is great. This is quite good. Okay, so we know that works. Let's put the analog right sketch back on it, because apparently I can't wire it up properly. Okay, things are still intact. I'm so gonna break this by the end of today. Upload. I should also give it a resting period, I think. Upload again. That's great. Come out, come out. Yes. Okay, this might be too little power. Or maybe the analog right just doesn't work. Do I have to do any initialization? Hope not. No. The LC library. curious how to do ESP32 PWM properly, basically with the API. Yeah, I know what PWM is. Let's see touch pin, let's see setup, let's see write. Okay. Docs. M5, sure. That's good enough. Oh. This link. Does this? No, okay, it has actual DAX. Okay, let's see setup. Okay, I'll do this. So, let's see setup. Channel 0, use whatever frequency, 1 kilohertz. And 8 bits of resolution. Channel 1 as well. Also, let's see attach pin. Attach pin. Pin 12 to channel 0. Pin 13 to channel 1. Remove the library. And instead of analog write, I'm gonna say, let's see, right, channel and duty cycle, okay. And channel 0, 20, and channel 1, 0, 0. Oh, I actually could do this. This seems slightly more elegant. And I hopefully won't fry anything. Okay, let's program this. Come on. Ding. Compile, it probably doesn't know what let's see is. It does, okay, that's good. Will it work this time? Okay, the motors do seem to be doing something. They whine. Maybe the duty cycle is way too low. Let's go for 80, I guess. And I don't know if you can hear them, but they do sort of follow the pattern of 1 second of something, 1 second of another thing, and then 1 second of silence. Let's go to 100, actually not 80. Okay. Pull this out without breaking it, please. Okay, try again. Thank you. Let's go again. Okay, it does do something, but let's go. It seems like 5 volts is a little bit too weak for these motors, or like, well, 5 volts and this 100 duty cycle, but they do spin properly. I'm curious if I hold them. No, nothing happens. Okay, but that is not enough to move it, which is kind of sad. Yeah, we'll have to see its max speed with maybe a 9-volt battery after I find a way to mount the buck converter without being an absolute idiot. Okay, but this is good news that one of the channels works. Making the other one work should be relatively straightforward, but I am going to try to restructure the board a little bit. Okay, that is over. Sit tight. Right. So pull everything out because I don't like this. We'll have to fix this into pin. That's very bad. It really did not solder. I thought the connection was made, but it actually wasn't, and it broke loose. That's horrible. Try to maybe press it down a little bit. I think it still does make a contact with the breadboard, but not a great one. Right, I've also got molten plastic on my soldering iron because I am a responsible person. Yes. I would have really enjoyed one of those solder sucker tools right now, but nope, I will have to do without. This pin is in awful condition. Well, actually it's not that bad. It's slightly shorter than the other ones, but I think it should make okay contact on the breadboard. You can't even see it. Oh, okay, because I angled it too much. But actually you can't. Okay, yeah, in any case, and I ran out of gas, that's good. I think it's gonna work now, and I think it has actual good mechanical contact. Right, let's dismember this breadboard and rebuild it with some actual perspective into what I want to do with it, not what just happened. these two wires were really badly chosen, so I'm gonna break off the hot glue, maybe even resolder them if they break now. I'm not happy with them at all. Okay, hot glue is off. And I think I'm gonna route all of the motor wires on the other side, so here rather than here, so that I can put the battery here. If only we would have had the budget to have an actual like 3D printed car or use Bosch's cars, but nope. Do it yourself. As a slight clarification, not to be an asshole, this is actually the best money to quality ratio we could do, because if I would have tried to 3D print a car, there would have been so many other issues I would have had to iron out. So using an RC car, we basically know the motors work, we know the wheels work, we know it is mechanically stable and all of that, and I only have to fiddle with electronics as opposed to fiddling with both mechanics and electronics. Right, where did I put? Here it is. Here's an idea. Maybe I could make it so that you place the 9-volt battery like this, and it sort of stays there in a slot. Let's try that. The chassis is a little bit tight here, but I think that will work if I glue down the 9-volt battery connector. Let's see. Okay. So I wanna glue this in place here, and sort of have to slot in the 9-volt battery and pull it out, and this would then become the back of the car, and this would be the front, and the camera would look that way. Let's hope it works. No, actually it's not even that bad. If I don't ambition myself to stick it in the most compact way possible, I could just let the 9-volt battery sort of flop around. Not even flop around. This might actually work. Surprisingly, first thing that would work today. And it's nearing on midnight. Would you look at that? So I'd like to put it here and here, maybe. Where are you gonna wanna stick? Place for a short while. What we were doing. Is it cooled? Kind of. Let's see. think that kind of stays. Maybe the breadboard would mechanically support it. I place it like this. Yeah, kind of, and I think the car won't move fast enough so that this becomes a problem. Oh yes, it will. Never mind. Could I pull this out? Not very comfortably. Yeah, that's not a good solution. Thing is, this car, basically this slot here was where the car's batteries would have fit, but it only runs off of 6 volts, and basically it's very, very slow. So that's why I wanted a 9-volt battery, at least give it a little bit of a boost. And while it fits very neatly like this, it doesn't leave basically any room for the rest of the circuitry unless I want to have it raised or on the other side, which I might go for. Maybe have the battery and power system on one side, yeah, like so. And this would be the bottom of the car. The battery sort of is flush with the wheels, and if I press it down, or maybe carve a little bit, a small slot for it, maybe this could work. Yeah, the battery doesn't touch when it's like this, but I'm not. This looks very, very janky. Very sunky. And yeah, with the connector, it still sort of fits, but I don't like this. Maybe like this. This could work. Basically, what my big issue is that I want them to be replaceable. I don't expect these batteries to last very long, maybe an hour, and I want everybody to be able to change them out easily. I don't want it to be a big and messy process to change the battery. So maybe I'll go with this. This sort of looks alright-ish. Come on, you can do it. It's a tight fit, pulling these wires through one of these small holes, but here we go. Will it fit? I might actually go for this. Not a great fan of it, but like with a little bit of scotch or electrical tape or something, you could also fix the battery and have it stay there, while also being sort of replaceable. But in this configuration, the power would need to also be on this side, which I'm not very happy with. maybe I could have the breadboard overhang a little bit and fix the power underneath it. That would be very weird. I don't like that either. This is awful. Ah! No, my battery fell. If only the car was like 1 centimeter bigger, one millimeter bigger, the battery would have fit perfectly inside of here. But Normally the car is like this. I think I threw away its top chassis. Maybe use these scraps as mechanical support. Okay, let's grab the battery from where it fell. Where did it fall? No, Mr. Battery. Could it fit here? Kind of. It would kind of fit. I don't like the way it hangs there, but maybe I can juggle it around, find some configuration in which it stays put. How much room do we have? Not a lot. Not a big fan of this. No, the last resort would be mounting the battery like that on the front or on the back of the car, but I really don't like that because it's gonna make it harder to replace. Maybe something like this could possibly work. Fix it in with some Velcro. Nothing at all, just electrical tape. It looks awful. It looks absolutely horrible. Like the car has a small PP. Still, the best way it fit until now is here. It's just so good, and it also fits with the breadboard and everything. But it's horrible aesthetically. But hey, who cares about aesthetics? Am I right? This is already horrible aesthetically from the way I've butchered it. So maybe this. I would have really liked if the buck converter fit underneath the breadboard, but it's just ever so slightly too tall. And you wouldn't be able to play with the trimmer. But I could place the power converter here, or something like this. Here. And the breadboard here, it has a little bit of an overhang, but it looks rovery, if you ask me. This might just be the best variant. to now. Something like that, and it's gonna see this way. And this way it also kind of lines up. You can't see on camera, and I won't try to bring it close, but on this side we have the converter's input, and on this side it's the converter's output, and I could maybe run some very short wires right from the input to this left rail, and right from the output to the right rail, to have separate power rails. It's kind of, I kind of dig this. I don't like the way the 9-volt battery wires sort of hang, but I can work with this. Maybe shorten them. I won't shorten them. But yeah, I like this. Oh, I could take these wires and put them straight to in the breadboard, and then take power for the converter from the breadboard. Maybe. I kind of like this. I'm gonna try it out. I'm a little bit unhappy with these wires because they aren't. They're multi-stranded. That's kind of a bummer, but I twisted it and turned quite alright. Maybe I could give them a little bit of solder and they'd stick properly. They'd hold their shape. Alright, and I can now use my ugly jumpers. These are too short. Okay, I'll try this. So, soldering time. Get this out of the way. Get the wires out of the way. Okay. So, I'm gonna want some moderately sized power cables here. I won't make them very long, won't make them very short, so that I can sort of fiddle with them and not be very limited, but also I don't want huge hanging wires. Right, okay. Plus this looks like a decent size. There we go. Roughly the same size, that's good. And it should be spotted at something. Sort of like that. Okay. And and also I'll do the same for the output, so that I can solder all of them at once. Positive. One thing I didn't, well, I don't want to say I didn't think it through. I knew it was going to be a problem from the start, but I didn't take any, I didn't try to avoid it, was that I think I only have one 9-volt battery, so I can't possibly both tune the output voltage of the converter and well, I can't power the converter and the multimeter required to tune it at the same time, which is suboptimal. I will look around for more batteries. I think I should have at least one more, but they might not be here in my dorm. Okay. Now, since I was out of gas, I'm gonna fill this up. Okay, stop. Wait for the propane to dissipate a little bit. I don't wanna cause any explosion around here. Alright. This fire really doesn't want to stay. Can I maybe rest you like so? Would you like that? Yes, you would. Of course, you would. Okay. Then this is some. Oh, it's propane butane mix. Okay, it burns considerably hotter or louder at least. I'm not sure that's a good thing for my circuit, because I don't know how to be very... this portable soldering iron already is too hot for most things. So a hotter burning mix doesn't help me very much at all. Okay, here we go. Like a good joint, yep. It's a little bit round, but I think it's gonna hold just right. I do have the impression that the wires aren't bonding. The solder seems to be bonding to the pad, but not the wire, and that's not. I'm not very happy with that. This one did seem to bond to both. and for some reflow I'm not happy. Should be good enough. Famous last words. This looks alright. Okay. What's that? Oh, it's the breadboard. Yes, it is. Of course it is. Okay. So I would have something like following setup. So inputs on that side. Actually, it really doesn't matter which side they're on. On some side. Okay, inputs on the other, and I will plug that there. The cables were a little bit too long, but it's fine. That looks nice. As long as the cables don't touch the tires, we should be good. Should maybe try to fix it in place with some glue or something. Just mechanically, elastically. Yeah, let's go. This is fine. This is the part where I burn everything and the battery explodes in my face. Okay, so a light, this guy's light is on. Can you see it? It's a red light over here at the top. That's good. I can't know what its voltage is, but I will look for a battery. Oh, I could look. Okay, so I have a lot of AA, AA and AAA batteries, but those aren't particularly useful in this case. Is this still not? Yeah, so I can't, I can't really do anything now, unless I either improvise a 9-volt battery out of a bunch of 1.5 volt cells, just to calibrate this, or I go get an actual 9-volt battery, but I would like to make some more progress tonight rather than tomorrow. Yeah, I'm gonna try something like this. I have the it's remote control, which is currently completely dead. I could do 3 volts with this, but no, that's not enough. I could use electrical tape to just tape 6 of these in series. Problem is I have 5. I need a 6th one, but I should have one here. Yes. And really I should move the 9-volt battery leads onto this rather than in the breadboard. I think that they're gonna be both more mechanically stable and, well, actually that's the only issue. They're not gonna be very happy staying in the breadboard. Right. Something like this. I don't need any extreme levels of precision here. I keep saying that, and it's so gonna bite me in the ass. And it has already, actually. Okay, let's didn't mean to do that. Alright. Not hot enough. Yeah, good enough. Melted a little bit of plastic, but that was to be expected. Here I should maybe bend these so I don't burn them. That's done. I'm not very happy about, but I can't change this about the actual 9-volt battery connector. The wires are very thin, so I think during the high power, in high power moments, there will be a lot of a huge voltage drop over them, rather than the voltage actually being used for moving the car. It's gonna be wasted because the wires are thin, but hey, not much we can do about that. I don't think there are any sort of accessible connectors with thicker wires. Okay, let's improvise a 9-volt cell while we're at it. Just let gravity do its thing and hold a couple of these batteries. Not enough paper. It looked diagonally. It's better. Everything's falling. Two, three, four, five. I would have liked another one. No. Okay. And the battery joint. Okay. Something like this baguette. So no. Okay, I have to try again, but it seems to kind of work. Okay, they seem to have contact. So, oh god, I can put the actually use the multimeter now and check that they do indeed work. Let's see. With a little bit of pressure, maybe. They don't seem to work. Oh god. Nope. No chance. They mount one of them backwards. That might be an issue. Okay, last one is negative here, positive here. Right. Please. Nope. Doesn't wanna. Oh, because it's on the wrong setting. Of course, it doesn't wanna. There we go. 8.5 volts. That should be good enough. God damn it. Okay. Right. How do I do this? So somewhere on my table should be the buck converter. I can't find it. This is such a mess. Okay. See some wires. They're not the buck converter. Where are you? Where did I put it? Let's. Here it is. Fell off the table. Right. Oh, yeah, okay, I know what I can do. Use some of these wires. Does it fit better? It does fit. Okay. And use some electrical tape to fix it on the end of the battery. Yeah. Let's go. Let's go. We're doing it. Next time, nota bene, buy the batteries you're gonna need, dumbass. But until then, I'm gonna have to do. Good enough. Right. Does the power light come on when I touch this? There, please go. Yes. Okay, it does come on. I can fix the other end with electrical tape as well, and we'll have the worst 9-volt battery ever used in the last century. Okay. And as long as these have contact, we have a red light. Okay, but I have to press them, which isn't optimal. And that one just wiggled its way out. Okay. Oh. I'm gonna also fix the potentiometer probes to the outputs, and while holding this pile with my mouth, I'm gonna try to tweak the adjustable pot. Okay, I don't have to hold it while fixing the other probes. Here's one. And here's a 2. Here's a disconnected wire. Okay, if I press these two together, okay, they actually stay. Good. Now I can. I won't show it on the stream, but the multimeter currently measures 7.5 volts, and if I play around with this spot I wanna bring it to about 3 volts. Okay, 0.3, 0. Oh, what's happening? What? The voltage dropped because I wasn't holding. Okay, I'm gonna actually hold it with my mouth. Very weird. It seems to stay at a stable 7 and a bit volts, even though I turn it quite a bit. Does it have like 20 turns? It does seem like it. Okay, I actually have to turn it a lot of times. I'll do that while not in an embarrassing position. Okay, fell down. Is it because it lost contact? No. Just jumped from 7 to 2 volts, and I want 3 and a bit. 3.3, 2.75, 2.8, 2.9, 3.33, 3.35 should be good enough. I want to check the tolerances on this. Okay, so ESP32 voltage spec. Do you have a table I could check, please? Okay. Those are the analog power supplies. No, I want the actual internal logic. Not analog power supply. But it does, maybe the internal logic also works on 2.3 up to 3.6, but I really wanna make sure. Input power supply for RTCIO, no. Come on. Output power supply, no input. Okay, input power supply for CPU IO, anything from 1.8 to 3.6. I think I'm gonna set it a little bit on the high side, maybe a 3.45. Sure, that's good enough. Okay, now that the hack is over, I can disconnect this mad baguette battery. And this is good. Unfortunately, I twisted all of my all of the contacts that were supposed to be straight, so it's gonna take a little bit of fighting to get them to fit in the breadboard again. Alright. Here as well. That's straight enough. Now, okay, so on the breadboard I should be able to use this side as the high power side, the other side as the low power side, and hope to have, okay, it doesn't really want to fit, okay, hope to have 3 and a bit volts over there. We can't measure it. Worst case, I burn a board. that's not very, that would be very good. I'd like to flash the webcam demo so that I can test that the high power draw sort of setting works, because right, the whole purpose of a power source and a more powerful battery is so that the Wi-Fi chip doesn't brown out the board. Hopefully this will be good enough, otherwise it's back to the drawing board. Good. Okay, you can go back to being powered. Plugged in. You don't care about this. Okay. Cool. That's right. Compiling sketch. And I will wire the 3.3 volts, converted 3.3 volts to the board's 3.3 volt input, hopefully without destroying it. So it's gonna be the closest one here. And also, okay, I could actually use normal jumpers for this. And ground, where is the ground? Two dots and then a ground. Dots and then a ground. Oh, and I better connect VCC rather than 3.3. Maybe 3.3 is the output of an onboard converter. So let's do it like this and like this. Are you uploaded? You are. Okay. Let's go. And please tell me that is ground and VCC. Okay. So if it works now, it's fully powered off of a 9-volt battery, and that would be awesome. God, I hope. Let's refresh. No, it's probably still browning out. I would like to use the LED to signal what's happening. So I don't think it's doing anything, which is unfortunate. What if I wire this up to 3.3? Wake up. It will not. Okay, I'll try to I'll upload the blink sketch so that I can see which power sources are okay and which aren't, and eventually if I've fully fried the board. Okay, for that now I wanna open blink. So while on the pair on its programmer, blink does work, and the LED is quite bright, so this might also help us test which power source would be best suited. So it works when I supply 3.3 at 3.3. Does it work when I supply 3.3 at VCC? It also works. Might the Wi-Fi actually be that stressful? Okay. That's not great. We'll set up here. Yep. I think it was. Right. Camera init. Works. I'm gonna make a function that blinks a number of times so that I can figure out. Ciao. Ne-am la laboratorul lui Dexter aici, în care îl nebunesc.
Ușa. Ce nebunești?
Pare că nu merg chestiile.
Vrei ca isă? Ca isă. De acasă.
Yes, please.
Shoulder you can have to.
Voi pierdea că te-ai la mare.
Da, da. Vrei să-ți eliberezi masana? Cred că vrei, da.
Ai văzut încă să dai de asta mare, nu știu. Vezi că se asta în camion. O așa, nu. Deci, acum sperăm să fiți ca să o sunat în camion de la ani. Știi ce? Da, asta avea numai cum era. Ai cred că depășesc 20 de dar